Alright guys, so today we're going to learn how to find the missing angle in a right triangle. It's actually easier than finding a missing side of a right triangle. This is actually the third time I'm recording this due to interruptions and just a tiny mistake on my part. Originally I'd mislabeled the sides of the triangle so that they actually weren't a possible right triangle, but as long as the right triangle you have written is definitively a right triangle, this method will work, and it is very, very straightforward. We're going to find the measure of angle x, and we're going to do that by writing any of the three trig ratios for x. That's either sine of x, cosine of x, or tangent of x. It doesn't matter. We're going to be using sine, but I am going to check cosine and tangent with our calculator just to confirm that it didn't matter which one we used. In other words, you only need to know two of them. So for angle x, the opposite side is 8, and the hypotenuse is 10. So we're going to write that the sine of x is equal to 8 over 10. And just to have for completeness, we will also be writing the cosine of x, which is 6 over 10, and the tangent, which is 8 over 6. So the way this works is we're going to be using the inverse of sining something, because this says the sine of x is 8/10. So if I invert sine, the sine itself will go away. So the way that works is I put sine inverse on the left side of this equation with sine x, and the sine and sine inverse are going to cancel out. And the right side of the equation is going to say sine inverse of, 8 over 10. So pretty much what happens is you put into your calculator the ratio into the sine inverse. So what I'm going to do is I'm going to type second sine, I'm going to type 8 over 10, and I'm going to get x is equal to 53.13, approximately. So that should be the measure of x in degrees. If I did second cosine of 6 over 10, I should get the exact same thing, which you see we do. And if I do second tangent of 8 over 6, we should get the same thing as well, because they're all using the same angle, but they all have the correct side measurements written in an appropriate right triangle. If we wanted to find the measure of angle y, all we have to do is take 90 and subtract x from it. So y should be equal to 36 point something. So we'll just do that real quick. 90 minus 53.13 is equal to 36.87. So that is the measure of y by just completing it with the triangle sum theorem. But we also could have written a trig ratio for y. So for, let's say we wanted to use the sine of y. The sine of y is equal to its opposite side, which is 6, over its hypotenuse, which is 10. So we do second sine of 6 over 10. We should get 36.87 or something close to that. We get 36.869, which is approximately 36.87. So we get y is equal to approximately 36.87. Now, no matter what you do, whenever you're using the trig functions, you will be approximating, unless you happen to get a nice number like 0.5, which is very, very rare. All right, so we have one more thing I wanted to talk about today, and these are special right triangles. So the special right triangles we needed to know are the 45, 45, 90 right triangle. I've labeled the two sides here x, and that's because in a 45, 45, 90 right triangle, because two of the angles are the same, two of the sides are the same by the converse base angle theorem, meaning that these two sides are the same. There is a relationship between these sides and the hypotenuse. So we're just going to use Pythagorean theorem and see what that is. So x squared plus x squared will equal c squared. If we simplify this, we get 2x squared is equal to c squared. And if we take the square root of both sides, we get that x radical 2, because the x does come out of the radical, but the 2 does not, is equal to c. So this side measurement is x radical 2. And the reason that's relevant, that means if you have a right triangle with the two legs being 5, the hypotenuse, without doing any work, should be 5 radical 2. If it were 50, then the hypotenuse would be 50 radical 2. So nice property of the 45, 45, 90 right triangle. So let's take a look at the other example we'd like to do, which is the 30, 60, 90 right triangle. The way this works is I'm going to draw an equilateral triangle, and I'm going to measure the sides. I'm going to call them each 2x. I could call them x. I would prefer to call them 2x so we don't work with decimals. And what we're going to do is we're going to draw a altitude from the top vertice, and it'll form a right angle. So that would be, whoopsies, clicked off onto the wrong thing for a moment. I apologize. We'll draw an altitude. And then we can see that these two triangles are actually congruent because they share this altitude. They each have a right angle because the right angle is formed at the base of the altitudes, and we have the congruent angle of 60. So that makes these two triangles congruent by AAS. And the important part here is that that makes this an angle bisector by CPCTC. So that means this angle is 30 and this angle is 30. So in any equilateral triangle, you can split it into two congruent 30, 60, 90 right triangles. So that means that we have this triangle here, which is a 30, 60, 90 right triangle, where the hypotenuse is 2x and the base is x. Let's use the Pythagorean theorem to find the measure of the remaining side. And that would be x squared plus bx, I'm sorry, not bx, b squared equals 2x squared. So that is, if we were to simplify this, 2x squared is in parentheses, excuse me. So we'll get x squared plus b squared equals 4x squared. By subtracting the x squared to the other side, we get b squared is equal to 3x squared. And by taking the square root of both sides, we get b is equal to x radical 3. So the importance of this is that if we were to say that the side across from the 30-degree angle, if it were 5, will be half the measurement of the hypotenuse. So the side across from the 30-degree angle is always going to be half of the hypotenuse. And the other side does have a measurement that's relevant as well. It's going to be whatever the smaller side is times radical 3. And that's true for every 30, 60, 90 right triangle. So let's say this side was 10. What would the measure of this side be? And what would the measure of this side be?